previous video, we had seen what is a subgraph, what is induced subgraph, what is complement of a graph G, what is T-regular graphs, what is null graph, what is complete graph, what do you mean by vertex independent number, edge independent number, what is a matching, what is perfect matching, and what is near perfect matching. If you haven't watched the previous video, please do watch. It's in the description below. Now moving on to the new topics. Our partite graph. So what is our partite graph? If vertex set of G can be partitioned into R independent set V1, V2, so on up to VR, then this is called an R-partite graph. If R is equals to 2, which means that we have only V1 and V2, so this is called bipartite graph. Which has bipartitions V1 and V2. If every vertex of Vi is joined to every other vertex of Vj, where j and I are not same, then this is called a complete R-partite graph. And this is represented as O of P1 plus O of P2 plus so on up to O of PR, where these are all partitions, where Pi is equals to I can be 1, 2, so on up to R. Cardinality V. If G is a complete R-partite graph, which you know is represented by O of P1 plus P2 plus O of P3 plus so on up to O of PR, and if all the partitions have equal number of vertices, then this is called a balanced complete R-partite graph. And this is represented as K R comma N. Spanning subgraph of balanced. Before going to this, let me tell you what is a spanning subgraph. Spanning subgraph is nothing but a subgraph that contains all the vertices but need not contain all the edges of graph, say G. It's called a spanning subgraph. So spanning subgraph of a balanced complete R-partite graph is called a balanced are partite graph. So we have seen bipartite graph. It has two partitions, v1 and v2. So if v1, the cardinality of v1 is m, and the cardinality of v2, cardinality is in the sense number of vertices, is n, then this bipartite graph is denoted by k m comma n. As bipartite graph are represented by bipartite graph, so k1 comma r is a star graph. Bipartite graph will have m vertices here and n vertices here. Connection. Star graph has one and many different. So this is a star graph, and star graph is denoted by SR. So now that we have finished what is bipartite graph, partitioning of graphs and all, let's go to the next topic. Cycle of length n is represented as Cn. Shortest part of length n is represented by Pn. Path of n, cycle of n. Now let us go for Hamilton cycle. If G has a cycle, say C, which includes every vertex of G, then it is called a Hamilton cycle. Then the C is called a Hamilton cycle, and the graph G is called Hamiltonian. Next is Hamilton path. What is a Hamilton path? Similar to cycle, if G has a path P that includes all the vertices of G, then it is a Hamiltonian path. What do you mean by disjoint? Consider two graph G and H. The two graphs G and H are considered to be disjoint, are said to be disjoint if there is no vertex in common between graph G and H. Then G and H are said to be disjoint. So what is join? Join is G plus H. So G and H are two disjoint graphs. When we say G plus H is a join, which means vertex set of G plus H would be vertex set of G union vertex set of H, but H set of this join is H set of G union H set of H union xy edge xy, where x belongs to V of G and the vertex y belongs to V of H. For example, consider the following graph. So consider the following graph. Say this is G and this is H. So the join of G plus H will be something like this. So it will contain all the vertex. As shown here, it will contain all the vertex. So let me write. Contain all the vertex. So it will contain all the vertices. So G plus H will contain all the vertices. And when it comes to edges, it will contain edges of G, edges of H, and all the other edges. So this is join. Our next topic is union. What do you mean by union of G union H? So similar, G and H are disjoint graphs. G and H are disjoint graphs where G union H has vertex set P of G union P of H, means includes all the vertices of H and G, and H set has E of G union E of H.